I think you already know how to deal with the text pre-processing. Last time I run this code, so you can also run the code from your computer. So we usually use the NLTK, which is the Natural Language Toolkit, and sometimes we need to use string library, because the string library can give us some methods to deal with split or do some kind of searching on some character and so on. And RE, I think you already know, the RE is the regular expression. So last time we already learned, we need to lowercase. Lowercase means we want to make all the uppercase Demuncha to be lowercase. So if it is amazing, then it becomes amazing with lowercase. If it is hey with uppercase, then it will be lowercase. And then we learned already about how to remove the numbers using the regular expression, and then how we can change the number into words. So for example, if we have 3, like this one, then we want to change to 3, like this one. Remove punctuation. So we want to remove some of the punctuation like comma, question mark, looking to, exclamatory sign, and etc. And remove the white space. Remove the white space means if we find any space like this one, if there are so many space, so we can remove it. And we remove the stop words. So stop words, we know that it is not meaningful words. Not meaningful words, it means like in this case, if we have a sentence, this is a sample sentence, and we are going to remove the stop words from this. So the stop word will be is, we, are, and. It's something that are frequent, but it is not meaningful. So last time we learned about the stemming Porter. When you learn about the Porter stemming, it is one of the popular stemmer, and people still use for English. But for Korean, there may be another kind of stemming. And also in other languages, for example, Russia or Japanese or other kind of language like Chinese. So they also have another kind of stammer. So this is the very basic stammer, which is Porter stammer. And whenever we want to do the stammer, we need to first nice. Talk nice. Okay, so we want to split every sentence into word. So we will call the stammer, and then let's make a function. We want to tokenize the text. Okay. In this case, text is any kind of sentence, and we use the stammer. So the stammer means for every word in the word tokens, for every word that we already tokenized, then we will do the stemming. Means if we have the sentence like this one, data science use scientific methods, algorithm, and many types of processes. So we want to stem for every of this word. For example, data. Okay, this is the result from the stemming. Science, this is the result from the stemming. As you can see, in the stemming, they want to make the original word, but sometimes it results not an exact word. Like this one, science, the result has no E. Scientific, this one. When you finish the stemming, the word becomes scientific. There is no IC, or it is not a kind of word. Many, we know many should be MANY, but when you use the stemming, it becomes MANI. Okay. So this is one of the weakness using stemming. People try to improve with the lemmatization. So we learned already about the lemmatization, and there is one class in the NLTK. We can use the WordNet lemmatizer. So the WordNet lemmatizer is from also the stemming. We first again do the tokenize. So the tokenize means we will do the word from the long sentence. We will check for every word, and then again we will do the lemmatize. For this purpose, because we are using the WordNet lemmatizer, so it is necessary to download some of the resources. So in the NLTK, there are so many resources. So like, for example, Punk. So Punk is one of the resources in the Word. And WordNet is also one of the resources. If you use some of the libraries, you need to consider what are the resources that you need to download. So this is one of the good things using the Google Colab, because some of the resources, they exist in the Google Colab. So if you use Jupyter Notebook, or if you use Visual Studio, then you need to download all those things into your computer. So in this case, you don't need to download all of them into your computer. They can just be in the web. And we are using the WordNet lemmatizer. We still use the same text like this one, data science, use scientific methods, algorithms, and many types of processes. And the result will be something like this. Data, science. Now you can see science becomes a word after the lemmatization. Scientific. Okay. So scientific, it is still in this form. And then if you can see methods, okay, it is in the same form. Many, it is also in the same form. Okay. So people say that it is better to use lemmatization rather than stemming. So people use lemmatization instead of stemming these days. POS takers. So we already learned about the POS takers. Let's say I have this sentence. So whenever you do the text analysis, you need to understand what kind of resources that you need to download. So for example, I'm going to download the Punk. Okay, so this is the common resources for the text analytics. And in this case, I want to explain about the POS figures. Do you still remember POS? Okay. This is part of speech. So you can look at the chapter 2. So we have the part of speech tagging. So in this part of speech, we can see what is the pronoun, what is the verb, what is to, is there any noun, and so on. So the NLTK provide some kind of resources for the POS tagging. Okay, so one of them is the average perceptron tagger. And also we want to learn about the universal tag set. So this is also another resources that we can use based on the universal information. For example, if I know about the word like, so like is a verb. If like after a pronoun, then it is a verb. Like it can be a kind of noun if it follows with another word, and so on. So this kind of POS tagging or lemmatizer or stemming, every time if we want to run those functions, we need to tokenize. So every sentence should be tokenized. In this case, I would like to tokenize, and we want to do the POS tag. The POS tag means I want to get the part of speech. So if you look at this function, the POS tag, so it will show you what is the POS. For example, this is NNP. So it is the noun pronoun. S is just the POS. P. So they have the definition J, and N, etc. So we will take a look later. So we want to tag. We want to find the tag for the token. The token is from the tokenness of the sentence. The sentence is from here. And the tag set is universal. So universal can be used in any thing. So there are some other tag set. For example, WSG, round. So we call it, this is a corpus. So corpus is a kind of library. So it depends on what you are going to use. So if it is universal, then yeah, all people know about those tags. But if it is specific, like WSJ, it is, I guess it's like the Wall Street Journal or something. Yeah, it is different. So there might be some economic words. Brown. So they have also another corpus to define what is the tag, what is the tag, and so on. So you can run this one and you can see that the word the is a determinant, the word brown is an adjective, the word fox is a noun, and so on. So the current updates for the POS taker, people mostly use the pen free bank. Penn is from the Pennsylvania. So there is a university. They propose this POS taker, and people use tree bank a lot for this POS. So you can see this is the tag. Okay? So this is the information of the tag. For example, CC. The word CC means coordinating conjunction. So if it is and, but, or, so it is a coordinating conjunction. If it is CD, it is cardinal number. For example, 1, 2, and so on. So there are so many tags available, but yeah, you don't need to memorize this because it is not part of our course. So you can just reuse it. And usually we use this one to make the language in a good sequence. So people propose this one to make a good sentences. That's why in ChatGPT or some kind of GPT-based pre-trained model, they already embed with this tag. So you need to know about this tag, but it's almost impossible to memorize all of those things. After we learn about the VOS, I think you also know about the NER, name entity recognition. In this case, I'm going to use one of the library called spaCy. So spaCy is a library that are widely used for any kind of languages. So you can use for English, you can use for any other languages. If your sentence is in English, then it is recommended to use the English web resources. So I put this link. So this is the English pipeline for doing the text analysis. So whenever you use the spaCy, you need to figure out what is the language. If you are going to use the Korean language, then you need to find the spaCy for Korean language, and you need to load. So the library will be different. So if I use the NCore Web SM, so it means this is the library from spaCy only for English. So you can later find if you want to use the spaCy for Korean. Okay. So there's a way how to use the Korean. Yeah, you can use Core KO Core News SM. So you need to download this one, and then you can use to analyze the Korean language. Yeah, this is only just an option, how many rows that you want to display when you get the result. So there's an example that I adopted from one of the site. If you still remember the name entity recognition. So we want to specify, is this word represent a name or a noun or maybe some kind of tag. Okay. So if you run, we can see that Congress, it represents an organization. So ORG means an organization. Mahua Moitra, okay. So it represents a person. The Supreme Court, it represents organization. So using these sentences, Trinamool Congress, blah, 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 yeah, we can make the category, whether the word is an organization or it is a person. And if you see like this one, last week. So last week is a day. Then if you can make this classification, then it will be easier for you. For example, I want to know when it happens. So I will just focus to find date. So here is the NLP from the content, it means from the sentence. And the dot here, we want to find the entities. So for every word in the dot, let's check what is the text, in this case the text, and then where is the starting character and where is the end of the character. And I want to know what is the label. So this label is important. because it is the name of the entity. So the one that I explained before, the POS, it was using the NLTK. Is it possible to use the POS using SPACY? Yes, because there are so many libraries are available these days, and you can use any libraries for your analysis. But I think SPACY is very good, is very recent, especially it can adapt to many kind of languages. So let's say if you want to do the translation, you have to work in Korean and you want to translate to English, then using the SPACY, it result very good or natural languages. So this is the POS using the SPACY. As I mentioned to you, we need to load the library. It depends on the language. Because I'm using English, so I use the EN Core Web SM. And let's say this is the sentence. So those who can imagine anything can create the impossible. Again, I will do the NLP and the sentence. It goes to a variable doc, and we can find the token. So for every token, I would like to know what is the POS and what is the tag. So here you can see this is the POS, this is the part of speech, and this is the tag. The tag is something you can see from here. TT, WP, MD, PB, and so on. So those belongs to this one, who belong to this one, can belongs to this, and so on. Because we are in Korea, so I give you some code how to handle text in Korean language. If we are just using the word tokenization, it is not complex because we can use the string function in Python. The string function means, yeah, if we have this one, the language in Korean, I want to split. So just using the function split, so split is a function from string. So you can see if you put your cursor here, so the information is for string. So once you tokenize, then it will show every word, and if it is separated by space, it will be a different word. If it is there is a space, then it is a different word, and so on. Or we can also do with the character tokenization. The character tokenization means I want to split this on each of this character. So the hyun, gwa, sil, and then space, gu, gun, space, and so on. And in Korea, we know that we have the jam, home. So one of the library named Jamu. It is good to tokenize the Korean alphabet. So yeah, this is the basic one. If you want to know more about the ChatGPT, how the ChatGPT can create the language, they need to know every of the consonant and the vowel of the Korean character. So they need to know the jam and more. This tool is very good to create the Korean language. The JAMO, we can use the H2J, J to HCJ. Yeah. So it means we want to compose and decompose for every Korean character. For example, if we have this word and I want to decompose it. So after I decompose with this function, so I can make each of the letter into a list. Okay, so list means I want to make every of this character into a list, and you can see, yeah, this one is here, yo, nian, xia, in, real, and so on. Okay. So we can tokenize based on the Korean alphabet. In Korea NLP, there is one of very popular library. We call it the CoNLPy. So you can install it, the CoNLPy. And inside this CoNLPy, it contains some of corpus. So the corpus has been developed by some people. They developed this one to make us, the analyzer, the word analyzer, easy to analyze the word and the text. So we can use like the KKMA, Komoran, Hananom, OKT, Makeup. So this is the corpus provided by the GoNLP. So KKMA. So KKMA is a morphological analyzer and natural language processing system written in Java. And it is developed by the people at Seoul National University. So you can look at the GitHub. They give you for free, and we can install it immediately. We can also use it for the word analysis. There is another kind of class or library. They call it Komoran. It is Korean Morphological Analyzer. It is also written in Java, but we can adopt it to Python. So I also give you the GitHub for your reference, but people do not use commonly for this Komoran. KKMA is still good and it is still popular. Hanano. Hanano, it is developed by KAIS, but currently most of the methods are for the internal use. Even though you can still import from the CoNLPy, can import from here for NLPy, but many of the methods are for the internal use from the research. OKT. OKT is an open Korean text provided by Korean normalization and tokenization. And it is developed by Twitter. So we can use this one because it is very good for the normalization and tokenization. Makeup. Makeup, it is another library that is also good. And actually it is originally from a Japanese morphological analyzer. And this is also a POS tagger. It was developed by some people at the Kyoto University. But some Korean, they try to modify this morphological analyzer into the Korean language. So they adopt this one to Korean language. That's why if you use Makeup, some of them it is adoptable to translate from Korea to Japanese, Japanese to Korean, very good. Yeah, if you want to know more about the details, I give you this blog to understand all of those 5 libraries. So just very simple about the CoNLP. If you want to use one of the class, for example, OKT, Open Korean Text, So I can import it, and after I import this, I can make an object. So I hope that if you join the data structure and algorithm, you know we can make an object from class. So this is the class that has been available in the CoNLP, and we can create an instance or an object, and then we can define what is the sentence. So we can find from this instance, I want to know what are the nouns. I want to know what are the phrases. I want to know what are the mocks, and I want to know what are the POS. Then we can look at the result. What are the nouns? Okay, those are the nouns. And then we can know what are the phrases, and then we can also know what are the morphology, and what are the tagging. And I just show you with the KKMA. Using the KKMA, it is similar with the OKT. We need to import the KKMA, and then we need to make an instance. So let's say this is the text that we want to analyze. So we can check what kind of morphology that you want to analyze. For example, this is noun, sentence, mocks, POS. So the result is the same for the noun, but you can see now I'm going to look at the sentence. So this is one sentence. So we can from the slide, we know there are two tokenization. The first tokenization is sentence tokenization, and the other is word tokenization. So this one is how we can deal with the morphology. And if you can see the tagging, it is a little bit different. More is NNG, E is the BCP. If you look at this one, it is different. So it depends how you want to analyze. The library will give you different results. So this is the reference that you can look at. So this is the part of the text preprocessing. Now I'm going to look at the week 3. So we also already learned from last week. We used the count factorizer, and then we learned about the one-hot encoding, and we learned about the back of word. If it is one-hot encoding, it means the result is binary, 0, 1. So I want to know whether the word exists or not. If it is count factorizer, it means we want to see the frequency. So the frequency means how many times the word occurs. In this case, there are two. What is two? The confusing is love movie. Okay, the word movie appears 2 times. That's why the result is 2. So we learn also about the TF-IDF. We learn about the NLTK. So you know how to split, and then you know how to understand the grams last time. And we learned about the unigram, bigram, and trigram. So the bigram means only one word, the bigram means 2 words, and trigram means 3 words. So we already learned about the CPOW and skipgram. And I already teach you, if we use the word to fact from the GenSim, there will be some parameter like minimum count and SG. So minimum count means how many frequency that is limited, and the SG is the skipgram. If skipgram is 1, then it is we are using the skipgram. If it is 0, then we are using the CPOW. So let me skip this one, and I want to show you how we can do with the, I think I already explained this one. The last part that I have not explained is the glove. Glove, we know this is the global factor. It is a library from Python. We need to install it, glove Python 3. And to run the glove, we need to call the corpus and also the glove component. So the corpus, we need to make it as an instance. And then, because it is already a pre-trained model, so there are some models that already available in the glove and we can use it. So the tokenized corpus, it is from the word that so this is the word. Okay. So this is the word that I use to make the glove. So this is the tokenized corpus. It means I have the word and it has been tokenized for every single word. And there will be window equals to 5. It means the number of words before and after the token. So in the glove, there are already some parameters that you can define. For example, how many components? So it is the number of latent dimensions. And what is the learning rate? And what is the random state? So the learning rate means this is for the SGG estimation. And the random state, it is for the random state to initialize the optimization. So basically, this is just a library that you can use. You can define what you want to fit into this pre-trained model. For now, I will just use the similarity approach. So later, maybe on Thursday or next week, I will discuss how to apply this one to make the language model. And for the fast text, it is also the same. With the glove, we need to define what is the vector size, and then also about the window. It is the maximum distance between the sentence. So you already know, if we use the fast text and glove, we need to understand the surrounding words. And then the minimum count means how many words that available in the frequency. And then workers. So if the text is so big, then we need to use many workers. So if your computer is good enough or it has the multi-core machines, then you can use this one to make the program run faster. So the result will be similar with the glove because the text is very small. That's why you can see only this one. Okay, so that's the code that we can understand from the text preprocessing and text representation. For the language modeling, we will have another code and we will learn other tips. Okay.